CSEC Physics, and this is in January 2022 paper. All right, so it says in the figure 1 shows the arrangement of the apparatus used to investigate how pressure of a fixed mass of gas varies with the temperature of the gas. The cylinder is made of very strong material which allows it to withstand high pressure, and it is sealed so that there are no leaks. A temperature sensor is placed inside the cylinder to give an accurate record of the temperature of the gas over a wide range of temperatures. A pressure gauge is also placed in the cylinder to record the pressure readings. So here we have the apparatus, and so we're looking at the particles. So here we are looking at the particles on the inside, and so here we have the particles on the inside. So these are the particles. Okay, so in looking at the question, it says that we are to use the kinetic theory of gases to explain why the pressure of a gas increases as the temperature rises. Okay, so in order for us to do that, we need to understand what the kinetic theory of gas says. Now, as heat is applied to the cylinder, then what will happen is that these particles here will gain more kinetic energy, and because they will gain more kinetic energy, what happens is that they are going to move faster. And therefore there is going to be more collisions with the walls of the container. So because there are going to be more collisions with the wall of the container, then automatically the pressure will increase. Okay, so as the temperature increases, the particles will gain more kinetic energy. Thereby increasing the collisions with the walls of the container which will result in an increased pressure. Note, so we must also note at constant volume. So we need to remember that the volume is constant. How do we know that the volume is constant? Remember this, the statement we read that there were no leaks in the container, so therefore there was not the possibility of the gas or particles of the gas to escape. So therefore what we understood from there is that the volume was kept constant, and the volume was kept constant. It means then that as you increase the temperature, the gases will gain energy, the gas particles will gain energy, thereby increasing the collision with the walls of the container and thereby increasing the pressure. And basically that's the concept involved here. So the second part of the question is asking us to plot a graph, and here are the points that we are to plot. So we have the temperature goes on the x-axis while the pressure goes on the y-axis. At 25 degrees Celsius, we have 1.2. So we are to plot the graph of the pressure versus the the, the temperature on the Celsius scale. All right. So therefore, and if it were the absolute temperature that we were to do, we would have to convert these temperatures to Kelvin. But for for simplicity, I'm just going to use the Celsius scale here. So 25 degrees correspond to 1.2 times 10 to the 5 pascals. 50 corresponded with 1.3 times 10 to the 5 pascal. 75 corresponded with 1.4. 100 corresponded with 1.5. 125 corresponded with 1.6, and 150 corresponded with 1.7. And in this case now we're going to draw our line of best fit. And here, based on this information here, we would have realized that the pressure is directly proportional to an increase in temperature. Okay, so that's how we would have drawn this graph. So again, students, if you should get these questions, please do not be afraid to take the time to analyze the graph and plot the graph and draw your line of best fit and then interpret the information from the graph that is given. It says that the sentence below is an incomplete statement of the pressure law. Complete the statement by filling in the blank spaces. And it says for a fixed mass of gas at constant volume, so remember the volume must be constant. The pressure is directly proportional to the absolute, and this is the absolute temperature of the gas. And so the absolute temperature here represents the what? The Kelvin temperature. Okay, so remember when we talk about absolute temperature, we're talking about the Kelvin temperature. Okay, and now experiment on page 6. The pressure of the gas is 1.2 times 10 to the 5 pascal at a temperature of 25 degrees Celsius. When the cylinder is heated, the pressure reaches 2.1 times 10 to the 5 pascal. Calculate the temperature of the gas in degrees Celsius at this pressure. Now, one of the first things that we first need to do is to recognize that whenever we're dealing with the gas laws, we are using the absolute temperature, and the absolute temperature again is a Kelvin scale. So all temperatures should be converted to Kelvin. That's one of the things that we need to remember, right? So, and we're using the pressure law, and the formula for the pressure law is P1 over T1 is equal to P2 over T2. So let's just identify pressure 1. So pressure 1 is equal to 1.2 times 10 to the 5 pascals. P2 is equal to 2.1 times 10 to the 5 pascals. And T1 is equal to 25 degrees Celsius, or 25 plus 273 is equal to 298 Kelvin. And T2 is the unknown because that's what we are asked to find. So therefore, by just plugging in the values, so we have 1.2 times 10 to the 5 over T1, which is 298, is equal to 2.1 times 10 to the 5 pascals over T2. Now, so transposing the formula, where T2 will go up because we want to make T2 the subject. 298 will go on that side, and then so therefore, so we have 1.2 times 10 to the 5 times T2 is equal to 2.1 times 10 to the 5 times 298. All right, so we know that 10 to the 5 will cancel 10 to the 5 here. So T2 actually equals to 2.1 times 298. And then since the operation of this 1.2 is multiplication, when it comes across the equal sign, it will become divided. So therefore it's 1.2. In doing that, we have a temperature of 521.5 Kelvin. Because remember, we're talking about Kelvin. So in order for us to get that into degrees Celsius now, we have to subtract 273 from the 525. So it's 521.5 minus 273, and that would be equal to 248.5 degrees Celsius. So the temperature in degrees Celsius is going to be equal to 248.5 degrees Celsius. And that is how you would have approached this question. So again, remember the first question on the paper will be a graph question. So therefore, take some time to look at the question and do it. Okay? Yeah, have a blessed and wonderful day.